exam. Okay, we'll dedicate the next 5 or so minutes doing this. Okay, so what you're looking at here is H2 plus I2 is at an equilibrium with 2HI. Okay, so initially in our ice table, okay, they have 0.035 molar of this hydrogen iodide gas. Okay, but you know this is not the end because it's in equilibrium. Some of this will go this way. Okay, some of the reaction will go this way. All right, and they give you the K equilibrium constant as 50.5. All right, some of it's going to go this way because this is what you start off with initially, and then you have 0, 0 of H2 and I2. So some of it's going to go this way. So it's going to be minus not 1x, but 2x, okay? Because look at the coefficient here, it's 2. This has 1 as a coefficient, so it's plus x, and this will be plus x, okay? So at equilibrium, this would be x for the H2, x for the I2, and 0.035 minus 2x for the HI. Okay. Let me just do this here. Okay, what is the equilibrium concentration of H2, I2, and HI after 0.035 molar of HI is added and the reaction reaches equilibrium? Okay, that's the question. Okay, so initially you have this, you have 0 and 0 of that. It's going to go to this side of the equation, so this is minus 2x, okay, minus 2x because of the 2 here, plus x and plus x. So now what you'll do is you will just plug it into the equilibrium equation. Okay, this is the equilibrium concentrations, x, and 0.035 minus 2x. And then that's going to be 50.5, and that's 0.035 minus 2x squared. Okay, H2 is x, I2 is x, so what's x times x? Okay, x squared. All right, so now we will solve for x. Okay, so the way you'll solve for x is that you'll square root both sides of the equation. What time is class over? 1:50. Okay, yeah, that's what I thought. So we have 9 minutes. Okay, I'm thinking 1:45. I don't know why. Okay, so take square root of both sides of the equation. What's the square root of 50.5? 7 something. $7.106. 7.106, yeah. Okay, what if I square root this and this? I square root 50.5 on my calculator and I got this. Square rooting a square just removes everything. So this is actually 0.035 minus 2x over x. Okay? So if you square root x squared is x. If you square root 0.035 minus 2x whole squared, it's 0.035 minus 2x. Okay, so we'll solve for x here. Okay, we'll move the minus 2x to this side, so 7.106x plus 2x equals 0.035. Okay, I'm just moving this to the opposite side of the equation sign. So 7.106 plus 2x is 9.106x is equal to 0.035. So x is going to equal to 0.035 divided by 9.106. And what is that on our calculator? 3.84 times 10 to the minus 3. Here you want to put your units of molar. Okay, molar. So we'll definitely take off points if you don't have the right units. So the concentration here is molar, moles over liter. So what does this mean? That X is the concentration of H2 at equilibrium. This X is the concentration, is this X, which is the concentration of I2 at equilibrium. And then this X that we just solved for is the concentration of 0.035 minus 2X. So finally, we will write as our final answer, okay, at equilibrium, when this reaction is all settled, the concentration of H2 is X, which we got as 0.0038 molar. Okay, the concentration of I2, which is X, which we found X here to be 0.0038 molar. And then the concentration of HI is 0.035 minus 2X. We found our X here to be 0.0038. 0.00273, 0.027. Okay, yeah, something like that. Okay. So this is our answer. So that is what you want to put on your test. Okay, for a problem similar to this. How do you know you did get the right answer? Okay, how do you know? You can plug all of these back in here. Okay. You plug it back in here. And what should it equal to? Okay, it should equal to 50.5. So the equilibrium concentrations, when you plug it into the equilibrium expression, should equal to the equilibrium constant. Okay, so let's go ahead and do that. HI squared, what's 0.027 squared? Divided by H2 and I2, 0.0038 times 0.0038. Yeah, 50.48, which is 50.5, yeah. Okay. All right, so on Friday we'll have another review for this test on Monday. Turn in your quiz 2 on Monday, unless you want that to be your drop. I drop one quiz, and we will review the test on Friday. If we have time, we'll also go more into Chapter 15. I will tell you for the Chapter 15 that I derived, there's no derivation on the test. You just need to know those equations. Okay? And once we get back into Chapter 15, we'll go over some practice problems. We'll go over some problems for Chapter 15. 0.035 minus 2x. Yeah, make sure you study this for the test. Okay, the same procedures. Probably the only thing that changes is the number, but this is what you'll have to go. Okay, this is the pipeline.